One of the most anticipated astronomical events is the Betelgeuse Supernova, located on the famous shoulder of the Orion constellation. Betelgeuse is a red supergiant star that is nearing the end of its life cycle. However, when scientists pointed their most powerful telescopes toward the massive red giant, they were astonished to see that the dimming effect was still evident, even though the star's brightness eventually returned to normal after a few months. This sudden and unexplained dimming has led many to speculate that Betelgeuse is on the verge of a massive explosion. But when exactly might a supernova occur, and could it have catastrophic consequences for Earth? Let's explore these questions further. The brilliant, ruby-red star Betelgeuse is situated in the upper right shoulder of Orion, the famous winter constellation also known as the Hunter. Some may recognize it by its alternative name, Alpha Orionis. It is the second brightest star in the Orion constellation, ranking just behind the blue supergiant Rigel. However, despite Rigel's superior brightness, Betelgeuse remains one of the most fascinating stars for astronomers due to its variable behavior, striking reddish hue, and peculiar name. In general, stars labeled as Alpha, a constellation, are the brightest, but Betelgeuse is an exception, as Rigel outshines it. Nevertheless, Betelgeuse, also known as Alpha Orionis, is one of the most well-known stars in the night sky. It is the 10th brightest star overall and the 7th brightest star visible from most of North America, Europe, and Canada. The name Betelgeuse is derived from an Arabic phrase meaning the armpit of the giant, which fits its position in Orion. The exact distance of Betelgeuse from Earth remains uncertain. However, scientists estimate that it lies between 430 and 724 light-years away. What makes Betelgeuse even more remarkable is that it is the closest red supergiant star to Earth. Among the roughly 200 known red supergiant stars in the Milky Way, Betelgeuse stands out due to its brightness and proximity. It is about 16 times more massive than the Sun and emits an astonishing 126,000 times more light. It can be seen clearly from a distance of approximately 548 light-years. Compared to the Sun, Betelgeuse has a much lower surface temperature of around 3,600 Kelvin, making it a cooler but significantly larger and more luminous star. Interestingly, only about 13% of its total energy is in the form of visible light. If we could detect all wavelengths of light, Betelgeuse would actually appear more luminous than Sirius, the brightest star in the night sky. Astronomers estimate that Betelgeuse is roughly 764 times the Sun's radius in diameter. If this massive star were to replace the Sun in our solar system, its influence would extend beyond Jupiter and the asteroid belt. This means that it would completely engulf Mercury, Venus, Earth, and Mars. As a red supergiant, Betelgeuse constantly sheds mass, losing about 1 solar mass every 10,000 years. This process occurs as the star ejects material unevenly in all directions, forming a surrounding nebula. The nebula around Betelgeuse is estimated to be approximately 30 astronomical units, 30 times the distance between the Earth and the Sun, and is around 250 times larger than the star itself. At the core of Betelgeuse, hydrogen atoms undergo fusion under immense gravitational pressure, creating helium in a powerful nuclear reaction. This process releases vast amounts of heat and light energy, which travel to the star's surface and are emitted as photons into space. However, as Betelgeuse nears the end of its life, it will eventually deplete its hydrogen fuel. At that point, the star will start fusing heavier elements like helium and carbon to maintain its energy output. Once all available helium is exhausted, carbon and neon will continue fusing until iron is formed. This marks the beginning of the end for the star. Unlike previous fusion reactions, the formation of iron does not release energy. Instead, it absorbs it. As iron accumulates in the star's core, gravity will overwhelm the outward pressure generated by nuclear fusion, causing the core to collapse inward in a matter of seconds. This catastrophic collapse will trigger a powerful supernova explosion, releasing an energy output equivalent to 10 billion suns. Supernovae are among the most powerful natural explosions in the universe. The color of a star provides clues about its age and evolutionary stage. Younger stars typically appear blue, while older stars take on a reddish hue. Interestingly, the Greek scholar Ptolemy, who lived between 90 and 168 AD, described Betelgeuse as ruddy in color. However, ancient Chinese astronomers noted that Betelgeuse once appeared yellow, leading some scientists to speculate that it may have been a yellow supergiant in the past. Massive stars like Betelgeuse burn through their hydrogen fuel much more quickly than smaller stars, which accelerates their life cycle. Despite its massive size and brightness, Betelgeuse is only about 10 million years old, meaning it is relatively young compared to stars like our Sun, which has a lifespan of about 10 billion years. When Betelgeuse eventually explodes as a supernova, it will be one of the most spectacular celestial events in human history. The explosion will be so bright that it will be visible even during the daytime, potentially for weeks or even months. While a supernova of this magnitude would be devastating if it occurred closer to Earth, Betelgeuse is far enough away that it poses no direct threat to our planet. However, astronomers will continue to monitor the star closely, as it remains one of the best candidates for a nearby supernova in the near future. Unquestionably, Betelgeuse is in the latter stages of its existence. However, in contrast, our Sun, despite being over 5 billion years old, is still going strong. Betelgeuse, a massive red supergiant star, is nearing the end of its lifespan, which suggests that it may eventually explode as a supernova. However, the exact timing of this event remains a topic of debate among astronomers. One of the key aspects of Betelgeuse's behavior is its cycles of dimming and brightening. It undergoes such cycles, with the second one occurring every 5 years and lasting for approximately 100 days. Scientists assume that during these cycles, the star's outer shell expands and contracts, leading to changes in its diameter and average temperature. Public interest in Betelgeuse skyrocketed due to its erratic dimming in 2019 and 2020, followed by a temporary return to its usual brightness. Many astronomers speculated that this unusual dimming could be a sign that the star is approaching its final moments before a supernova explosion. Extensive studies of Betelgeuse date back as far as the 1st century BC, yet the cause of its sudden and atypical fading remains unknown. What is certain is that Betelgeuse is a runaway star, speeding across the interstellar median at an astonishing rate of 30 kilometers per second. It was ejected from its original home within the Orion-1 association, a region that includes the famous stars forming Orion's belt. The immense speed of Betelgeuse has created a both shock and arc-like feature in space, where the star's movement compresses surrounding gas spanning over for light years across. Calculating the exact distance to Betelgeuse is notoriously difficult in the field of astronomy, as red supergiant stars present unique challenges for measurement. Many factors contribute to the complexity of determining Betelgeuse's true diameter. As a pulsating star, Betelgeuse's size is not constant. Instead, it expands and contracts over time. Additionally, the phenomenon of limb darkening affects its visual emissions, causing them to fade at the edges when observed from Earth. Another complication in defining Betelgeuse's photosphere arises from the presence of a circumstellar envelope, a vast shell of gas and dust ejected by the star. This surrounding material interacts with light, both emitting and absorbing it, making it difficult to measure the star's true boundaries. Since Betelgeuse's apparent size changes depending on the wavelength of light being observed, making direct comparisons between different observations becomes even more challenging. Despite all these uncertainties, one thing is clear: Betelgeuse's dramatic dimming has come to an end, and it may soon regain its status as the 10th brightest star in the night sky. Even though it is located at a great distance from Earth, Betelgeuse remains one of the most luminous stars in the sky, shining nearly 100,000 times brighter than the Sun. However, maintaining such immense brightness requires an extraordinary amount of energy, meaning that Betelgeuse is rapidly consuming its fuel. This accelerated rate of nuclear fusion speeds up the star's destruction. When Betelgeuse finally exhausts its fuel, it will collapse under its own gravity and trigger a spectacular supernova explosion. For a period of several weeks or even months, the explosion will make Betelgeuse incredibly bright, possibly reaching the same luminosity as a full moon. If this happens, the supernova will be so brilliant that it could even be visible during the daytime. But when exactly will this cosmic spectacle occur? Unfortunately, astronomers cannot provide a definitive answer. While it is possible that Betelgeuse could explode tomorrow, it is equally possible that it won't happen for another million years. The uncertainty stems from the unpredictable nature of stellar evolution. However, one question many people ask is whether Earth would be in danger when Betelgeuse eventually goes supernova. Fortunately, there is no cause for concern. Betelgeuse is located far enough from Earth that its explosion will not pose any threat to life on our planet. According to scientists, The minimum safe distance for a supernova to avoid causing harm to Earth is about 50 light-years. Betelgeuse, however, is more than 10 times that distance away, meaning that when it explodes, it will not cause any significant disruptions to our planet. Instead, humanity will be treated to a breathtaking celestial event, as an incredibly bright new star will suddenly appear in the night sky.